Today's problem is to find the middle of a given linked list. Suppose we were given this particular linked list. We need to find the middle. So for this, 3 and 4 are the middles. So as per the cal's problem, she wants to print the middle element as 4. And if the linked list is of odd size, the middle will be 3. So how we do? One naive approach is have a pointer and count till end. So what is the size of this linked list? 6. Divide it by 2, 3, and have a counter variable. Initially mark it with a 1 and have the pointer here and move the pointer till 3. So this is a 3. So 3 will be the mid one. So what is that? O of n plus, again we'll have to traverse half of the element, so O of n plus n by 2. So that is one approach, and another approach is two pointer techniques. We have two pointers, slow pointer and fast pointer. Both will be uh, pointed to the first element. The fast pointer jumps 2 steps, slow pointer jumps 1 step. So eventually, at the end of the when it comes to the end of the list, slow pointer will be half distance traveled and fast pointer will be full distance traveled. What I mean is, if we have this particular linked list, we have slow pointer and fast pointer points to the first element, that is head. Fast pointer jumps 2 steps, slow pointer jumps 1 step. Then fast pointer jumps 2 steps, slow pointer jumps 1 step. And then, so slow pointer is here now. And then fast pointer jumps 2 steps. As there is no 2 steps, we will have to handle this case here. For suppose we have another one. And fast pointer jumps 2 steps, slow pointer jumps 1 step. So at the end of the list, slow pointer is pointing to the middle of the linked list. So this is the two pointer technique. How we handle the edge cases, how we handle the even and odd cases, and how we handle the requirement that we need to print the second middle element, not the first middle element, when the linked list size is even, that we will see in the code. I'll explain that when I write the code. As we'll be given the linked list, the will be written the middle node and find mid, and we'll be given the list that might be head. Okay. We need to have two pointers. So even before we assign the 2 pointers, we need to check whether this head contains any value or not, or this head has only one. The list, does the list is null, empty, or the list contains only one element, then we don't have to go through the whole algorithm. We just can return a simple null or that particular head. So we'll do that corner case now. So if head is null, we simply return null because we don't have to do anything on this. If the head dot next is null, that means the list contains only one element, so you just have to return the head. And then what if the list contains more than one element? Then we need to have two pointers. One is a slow pointer, and that is initially assigned to head, and assigned in the sense pointing to, and another is a fast pointer. This will also points to the head. Okay, so we need to jump the fast pointer twice, 2 steps and slow pointer 1 step. In order to jump 2 steps, we need to at least check the very next element is there or not. Once we check whether the next element is there, then we can make sure that we can check again if it has another next element or not. Then we can move the fast pointer. So what I mean is the check will be while the fast pointer dot next not equal to null, fast pointer equal to fast pointer dot next. Okay, and then again we'll check if this particular fast pointer still has another node attached to it or not. Then only it'll move. If this is the last element, that means if it contains only single element, there is no point, right? If we do the fast pointer dot next, that will give us throw us the null reference exception. That is the reason why we need to check before we proceed moving the fast pointer furthermore. So if fast pointer dot next not equal to null, then only we move the fast pointer. So fast pointer equal to the fast pointer dot next. So by this time fast pointer moved 2 steps. The another one is we need to move the slow pointer 1 step. Done. We'll just have to return the slow pointer. That is what we discussed. So if you see here 1, 2, 3, 4, 5, 6. Let's execute this. Fast pointer and slow pointer are pointing to the head. Is the fast pointer dot next equal to null? No, it is not. So fast pointer will move here. And then if fast pointer dot next not equal to null, is fast pointer not next equal to not null. So then we'll move one more time fast pointer and move the slow pointer. Okay, and then again we come here, it's not null, move fast, and this condition not null, move again the fast and move the slow is here now. And then fast pointer, yes, it's not null, so fast pointer will be here. And then is fast pointer dot next, no, this fast pointer dot next is null, so it will not, and then it will go fast pointer dot next not equal to null, but yes, fast pointer dot next equal to null, we will execute the while. So where is the slow point here? Slow is here, so we'll return that. But our our goal is to return this second one, right? So what we need to do, we need to move the slow pointer not in the second check but in the first check. So as and when we do, we can move the slow pointer along the fast pointer in the first go. In that way, as we have already checked fast pointer dot next not equal to null, so we will not have any null reference exception for slow pointer. We are just moving along with the fast pointer. Once we move the fast pointer and slow pointer once, and then we check for the next null and then move the fast pointer. So this will be like this: 1, 2, 3, 4, 5, 6. Fast and slow will be assigned to the null, point to the null. Now fast pointer not next null, so fast will move and slow will also move. And now again check fast, and fast will move now. And again fast will move, slow will move, and again fast will move. And again fast will move, slow will move, and then this check will fail because this is null. And in the next to go, this we will exit the while loop and S is pointing here. This is the second max. So this is a small change. We just have to remove from here and put it here. Okay, that's it.